Hi, my name is Tegan, and in this video I'm going to talk about polymers. Polymers have become so important in our lives that it will be difficult not to find anything that doesn't contain them. These include plastic bags, Kevlar in bulletproof vests, and in medicine. Obviously, these are only a few of the countless number of applications of polymers. They have these properties because of how much their molecular structure and weight can vary. For example, polybutadiene has two different possible applications. A short chain, around 5 to 10 units long, can be used as a lubricant, and a long chain, over 1,000 units, is used to make tyres. So, what is a polymer? A polymer is a large molecule, or macromolecule, formed by linking small, repeated units called monomers. The process to make these polymers is called polymerization. There are several types of polymerization methods, but the one I'm going to focus on is called anionic polymerization. Anionic polymerization has three main steps: initiation, propagation, and termination. To start the initiation step, you need a strong electron-withdrawing nucleophile and a double bond. The nucleophile will attack one of the carbons on the double bond, and the pi bonds will break heterolytically to the other carbon. This is to ensure that carbon doesn't break the octet rule. A key aspect for this to work is that the negatively charged molecule can form resonance structures to keep it stable. For this example, these are the resonance forms of benzene. The new anion formed in the initiation step will become the initiator, or nucleophile, and react with the same monomer as before during the propagation step, and this will continue until it has reached the required length. Termination happens when the negatively charged polymer reacts with water, which is highly likely as the polymer formed is extremely sensitive to impurities. However, if a pure solvent or reagent is used, the reaction will continue until all the monomers are used up and will not terminate. This makes the reactive polymer end group living, and this is how block copolymers are formed. Block copolymers are polymers made up of two or more different monomers in the form of an AAA-BBB pattern. This pattern is extremely important in nanomedicine as it can be used to make Micelles for drug delivery. For this to happen, the polymer must be amphiphilic, meaning it is both hydrophilic and hydrophobic. These become very useful when transporting hydrophobic drugs, such as Taxol, around the body, as the drug would be washed out if there was no micelle. The use of these polymer micelles has shown to be very useful with regards to gene therapy. It has been considered as an alternative drug carrier to replace or work alongside viral vectors. This is when part of the virus's DNA is modified to infect cells with the required genome to reduce or stop the condition. However, most people are not comfortable using these vectors as the viruses used have caused several immune responses in the past and can mutate, which can make it useless or dangerous. Therefore, polymer micelles are being considered as they will have fewer side effects on the body. Scientists are currently researching how effective these micelles can be, especially when it comes to transporting plasmid DNA, or pDNA, from a bacterial cell. Using plasmids is something commonly done for treating conditions like diabetes. Obviously, these won't last for a very long time in the body, as they are usually taken up very quickly. To help reduce the uptake, the hydrophilic shell will be made up of polyethylene glycol, as it stops the body having an immune response against the micelles. This makes any sort of drug in the plasmids more effective, as it has increased the circulatory effect. This also means that less doses are needed. Unfortunately, the micelles currently under development aren't stable due to them having label bonds. This means that the metal ligand bonds are easily broken and undergo more rapid equilibration. This also suggests that there are some transition metals in the structure that are keeping these micelles somewhat intact. On top of this, some polymers used to make these micelles have had a very low affinity to the drug molecule, as well as a low loading efficiency. Overall, the use of the polymers in nanomedicine seems to be heading in the right direction, but there is still a lot of work to do. These polymer micelles will hopefully be very beneficial, as well as safe to use. Obviously, they aren't just being used for gene therapy. A lot of research has been put into cancer treatment and treatment of mental health. I've listed my references in the description below if you'd like to do any further reading on this. I hope you enjoyed the video and thank you for watching.